Hello, today's lesson objective is Tek A.2B. This comes from reporting category 2, properties and attributes of functions, where you will be able to demonstrate an understanding of those properties and attributes. More specifically, you will use the properties and attributes of functions to identify mathematical domains and ranges and determine reasonable domain and range values for given situations, both continuous and discrete. To begin with, let's get a basic understanding of domain range. Domain is the set of all x coordinates in a list of ordered pairs. So let's start by underlining what x coordinates are in this given set of ordered pairs. So domain is our x values. So for this particular list, our domain would be -2, 4, 6, and 8. Okay, so if the domain is the set of x coordinates, then it makes sense to say that the range is the set of y coordinates in the ordered pairs. So let's look at the y values of each of these ordered pairs. Now typically when we list these values in our set, we want to list them in order from least to greatest. So for this set that we've underlined here, we would actually begin with -11, then 7, then 15, and then 19. Okay, so our domain is these values, our range would be these values for this given set of ordered pairs. Alright, here's another example. Okay, so here's some more ordered pairs here. We're going to do it the same way. We're going to start by saying the domain is all the x coordinates. So let's underline the x coordinates. Okay, and so these are already in order from least to greatest, so we'd say 2, 4, 6, 8. Okay, and then for our y coordinates, those are going to be the numbers at the end. Now notice one of our y coordinates repeats. We have 3 here twice. So whenever one repeats, you don't need to write down twice. Just write down one time. So for our y coordinates, we're going to have 3, 5, and 9. Okay? Alright, that's all there is to finding the domain range when given a set of ordered pairs. X is our domain, Y is our range. Now, another way that we sometimes deal with domain range is we have a function, and within our function we are given a parameter, either the domain or the range, and we have to find the opposite. So in this example here, our function is f of x or y equals -3x plus 1. First, we want to determine what ordered pairs would belong to this function if we were given the domain to be -1, 4, and 6. And once we find those ordered pairs, then we should be able to determine what the range is based on those domain values. So let's begin by plugging in these x values. So we're going to start with -1. So when looking for f of -1, y will equal -3 times -1, so we're putting -1 where the x is, plus 1. So using our order of operations, we'd start with -3 times -1 to get -3, and then we'd add 1 to that to make -2. So our ordered pair for this first one is -1, -2. Okay. For the second one, when x equals 4, we're trying to find f of 4. So that means we're going to replace x in our function with 4. Again, using order of operations, -3 times 4 would be -12. Add 1 to get -11. So our ordered pair for this one would be 4, -11. Okay. Our last one, when x equals 6, we're trying to find f of 6. So again, we're replacing x with 6. So we're going to do -3 times 6 is -18. We're still going to add the 1. That's part of our function rule. So -18 plus 1 is -17. So our final ordered pair will be 6 and -17. Okay. So the range of our function for f of x equals -3x plus 1, based on our given domain, is going to be our set of y values, -2, -11, and -17. So we're going to ignore the extra space that's been provided, and we're going to write these in order from least to greatest. -17, -11, -2. And again, we're just going to ignore this spot. Alright, so this is how you go about finding either the domain or the range when given the opposite for a given function rule. Now, a more common situation where we need to know the domain and range is when we're given an actual scenario. And based on the clues from the scenario, we should be able to come up with an appropriate domain or range for that scenario. Here in this example, it says the number of shoes in n pairs of shoes can be expressed by the function s equals blank n. So think about it. When you buy a pair of shoes, how many shoes come in a pair? 2, right? So for each pair of shoes, if we want to know how many total shoes we would have, we would multiply the number of pairs by 2. Agreed? So it says, are there any values that would not be reasonable to include in our domain or range for this given function? The domain of this function is the set of values you may choose for n, which is our independent variable. Okay, it's our independent because it's the one doing the controlling in this equation. Okay, it's also n is taking the place of our x in our equation, and x is always the independent variable. Okay, so it says, would it be reasonable here to let n equal -2 if n represents the number of pairs of shoes? So can you own -2 pairs of shoes? Not really. So we're going to say that does not make sense. Okay, so then our domain for our set of functions would be all the positive integers. So it's a set of all positive integers. Okay, now you might have 0 pairs of shoes in your closet, right? So technically it starts at 0, but from there we're going to be counting up only on the positive side. We're going to ignore the negative side of the integers. And we're also not going to include decimals or fractions here because it wouldn't make sense to say you own 2 1/3 pairs of shoes, right? You either own 2 pairs of shoes or you own 3 pairs of shoes. Okay, so we're just looking at from 0 and then any positive integer after that. So 0, 1, 2, 3, and these 3 dots indicate that that could keep going. Okay? Alright, so it would not be reasonable to include any other values in our domain, agreed? So the range of this function is the set of values that you will obtain for the dependent variable. Okay, dependent variable. So dependent variable is the one that's being controlled by the independent variable. Okay, so in this case, s is acting like our y, and our y is always our dependent because it always depends on the x. Right, and so the number of shoes in n pairs of shoes is going to be our s value. So it says, is it possible then to get 5 as a value for s? So if n is the number of pairs of shoes and we're multiplying that by 2, are you ever going to get an odd number for s? Well, no, because anytime you multiply by 2, you get an even number for the result, right? So this is not possible. You're not going to have an odd number for your number of pairs of shoes you have, or your number of shoes you have, I'm sorry. So it says, could a set of pairs of shoes have 5 shoes? Well, no, because again, you're not going to have a pair of shoes with 5 shoes in it, right? Because you're only going to have an even number of shoes. So the range of this function is the set of multiples of 2. Okay, so the set of multiples of 2. Because we're going to start with, when you have 1 pair of shoes, you're going to have 2 shoes. And then when you have 2 pairs of shoes, you're going to have 4 shoes. 3 pairs of shoes will give you 6 shoes. So it's all the multiples of 2's that are your possible number of shoes. Now if you have no pairs of shoes, you have 0 shoes still. But if you have 1 pair, you're going to have 2 shoes. 2 pairs will be 4. 3 pairs will be 6. And so on and so on. Okay? So it would not be possible to include any other numbers in our range, right? Or reasonable. It would not be possible or would not be reasonable to include any other pairs of shoes. Or I'm sorry, any other number of shoes, I should say. So 0, 2, 4, 6. So basically our even multiples of 2 here. Those are the only thing that would be reasonable for our range. Okay? So even though when I graph this, if I were to graph s equals 2n as it is, that's a linear function. And so if I just simply graph the line that represents y equals 2x, that would not be real accurate to represent this particular scenario. So we have to take that into account when we're thinking about how to graph this thing by looking at our domain ranges for this given function. Okay, let's look at another scenario. Consider the function L equals 4h, in which L equals the number of legs on h number of horses. So it says, are there any values that would not be reasonable to include in our domain range of our function? So the domain of this function is a set of values you may choose for h. Okay, again, our independent variable. So I'm just going to abbreviate that IND. So it would be reasonable. Would it be reasonable to let h equal 1.2? Well, if h is a number of horses, you're probably not going to have 1.2 horses, are you? You're only going to have one horse, or you're going to have two horses. You're not going to have something in between. So again, we're looking at just the positive integers here. We're not going to be looking at fractions, decimals. We're not going to have negative number of horses. All right, we're just looking at the positive whole numbers. So again, you could have 0 horses, 1, 2, or 3. Okay, so it would not be reasonable then to include any other values for this domain. All right, these are the only possible values that would make sense. Okay, so then based on this, based on our domain, the range of this function is a set of values you will get for the dependent variable L. Again, I'm going to abbreviate this just DEP, but dependent variable L, the number of legs for a group of h horses. So is it possible to have 6 as your value for L? No, because if you notice, each horse has 4 legs. So if you have one horse, you have 4. If you have 2 horses, you have 8. So you're not going to have a combination that gives you 6 legs. So the answer to that would be no. Okay, so for this one, the range is the set of multiples of 4. So again, if you have no horses, you have 0 legs, but beyond that, it's going to count by 4s. So you're going to have 0, 4, 8, 12, so on and so on. Okay, so it would not be reasonable to include any other numbers in the range. This is only the multiples of 4 would make sense. Okay, so again, your scenario sometimes dictates or determines what your possible domain range is for your function. Okay, let's take a look at this one. A computer store estimates that its monthly return, profit or loss, R, could be described as a function of its total sales, S, for the month using the function R equals 0.20 times S minus 250. What is the set of numbers that would be appropriate for this domain range? So for this one, the domain of this function, okay, so our domain of this function is the number of dollars the store has in sales for the month. So this can be any positive, well, yeah, any positive real number, because you're not going to have negative sales, right? You either sold nothing or you sold something, but you didn't sell negative amount. Okay, it doesn't mean you can't have negative profit, it just means you can't have negative sales. All right, so therefore the domain of this function is S can be any dollar amount that's greater than or equal to 0. So then based on that domain, our range for this function is the number of dollars the store has in return for that month. So the minimum return, which would occur with a sales amount of $0. So if I sold nothing, that's going to give me my minimum return for that month. So if S were to equal 0, then R would equal 0.20 times 0 minus 250. Well, we know that 0.20 times 0 is still 0. And then we take away 250, that gives us a return of negative $250. So the store would show a loss of $250 if you didn't sell anything that month. Okay, so any sales that are greater than $0 would result in a greater return. So therefore the range of this function is you're going to have a return of something greater than or equal to $250, because that's the lowest amount of return you can have. Okay, so our sales would start at 0 and go up, our returns would start at negative 250 and go up. And in that instance, you could include decimals. Okay, the final example I want to show you here is sometimes we had to come up with our domain range based on our graph. And so based on our graph, you're just looking at how low the x value goes, how high the x value goes for our domain, how low the y value goes, and how high the y value goes for our range. Okay, and so that will give you your domain range when given a graph. That's the only difference. So I just wanted to indicate that real quick.